Well, hello there. Hope you are having a great day and that you were absolutely amazing for Mrs. Bryant. So, we're going to be spending a few minutes talking about transformations. Transformations fall into four categories. They're either rotations, or I'm sorry, five categories. Rotations, reflections, dilations, and translations. And so on your notes that you have in front of you, I'm going to be going through those. I'm not going to go through everything because I think a lot of this you already know how to do, but I do want to try and cover as much of it as I possibly can. So the first thing we're going to look at is this page where you have this little table thing that you're supposed to fill in. And so the word that means to slide is a translation. The word that means to slide is translation. An illustration of that would be if you had a rectangle or a square, whichever you call that, and you moved it to here. The shape doesn't change. Well, I mean, I know mine did because I can't really draw well. Y'all know that. But the shape in general doesn't change, but the location of it changes. This second example here is a picture of a reflection. This is an example of a reflection, and a reflection is also known as a flip or a mirror. It's a flip or a mirror where you flip the angle. Not mirror, sorry. Okay, it's a flip or a mirror. All right, the next word, rotation. To rotate something means to twist or turn. So an example of this would be if we had a square that looked like this. I'm going to draw some marks in here because this will kind of help you out. And I rotated it. Well, if I rotate it, I take the shape and I turn it sideways so it would look something like this now. I took the shape and I rotated it to the right. Okay, the word that means to shrink or enlarge is a dilation. It's a dilation. An example of that would be if I had a decently sized rectangle and then I made a smaller version of it, or if I had a much bigger version of it. Thing you need to know about dilations is that they are made possible by what we call a scale factor. So whenever the scale factor is, you multiply by the scale factor. You multiply by the scale factor, whatever that is. If it's 2, then the picture is going to get bigger. If it's 1/2, then the picture is going to get smaller. The last one is tessellation, and that's one we don't see a whole lot, but at least not in math, but you do see it a lot more often in the real world. Tessellation is a repeated pattern. It is a repeated pattern. An example of this would be if you just think about kitchen tile is often a tessellation. We're going to be making this what our project's going to be. An easy example I can draw you of a tessellation would look like this, where you have a shape that fits inside of itself over and over and over again, and that is continually traced. Okay, that would be an example of a tessellation. So the next portion of your notes, the next page actually has some examples on it. And again, we're not going to do all of these. I'm just going to do a handful for time's sake. So example 1, we're supposed to translate. If y'all remember, translate is to slide the figure left 6 and up 8. So if we were to take point A and move it left 6, I'm going to go 1, 2, 3, 4, 5, 6 units to the left. And now I'm supposed to go up 8. Well, 1, 2, 3, 4, 5, 6, 7, 8. I would end up here. And the coordinates of this point would be negative 1, 2, 3, 4. So my first half would be negative 4. And then positive 1, 2, 3, 4, 5. So the new coordinates of A would be negative 4, 5. And you would do the same thing with B. You would take B and you would move it 6 to the left. 1, 2, 3, 4, 5, 6. And you would move it up 8. 1, 2, 3, 4, 5, 6, 7, 8. And that one would end up at negative 4, positive 1. And you can continue that with every single one of these. And what you would find is that eventually your shape that you end up with here will look identical to this shape because it's not changing sizes, it's just changing locations. So for example 2, we're supposed to describe the translation from part A to part B. And to describe that translation, we would pick a point on A. It doesn't matter which point. I'm going to pick this one right here. And pick a point on part B, which I'm going to pick this one right here because it's the same point. You need to make sure that whatever, if you start in the top right corner, you end up in the top right corner. And our job is to figure out how to get from this point to this point. Well, to go there, I would go down 1, 2, 3, 4, 5. So I'm going to go down 5. And then I'm going to go to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would go to the right 10. So all I'm doing is counting how I'm getting from this point here in the corner to this point here in the top right corner as well. You would do the same thing to get from B to D. You would pick a point. You could pick the top right every time, and that's fine. You figure out how you get from the top right to the top right. Same thing for D to C. For examples 3 and 4, we are going to be talking about how to reflect across different axes. The example, the x-axis and the y-axis. Sorry, I keep losing my space, losing my place here. So, for example 3, we're going to reflect each of these points across the x-axis. And the way we reflect across any axis, but especially the x-axis, is we count how far away the point is from the x-axis. So right now, point A is 1, 2, 3, 4 units away from the x-axis. When I reflect it across the x-axis, it's still going to be 4 units away from the x-axis. It's just going to be on the other side. So I'm going to go 1, 2, 3, 4 and end up here. My new coordinates of A would be -3 and -4. Originally, A was -3 and +4. And something I want you to note is that what changed was this. The x's stayed the same. They were both -3. But my y went from being +4 to -4. And that's what's going to happen every time you reflect across the x-axis. The y value will change signs when you reflect across the x-axis. Again, when you reflect across the x-axis, the y value will change signs. Example 4 talks about reflecting across the y-axis. Well, I'm supposed to translate or reflect each of these points across the y-axis, so we're going to look at point x. Well, right now, x is at the ordered pair -2, +3. And it is 2 units away from the y-axis. So when I reflect it across the y-axis, it's still going to be 2 units away. It's just going to be 2 units on the other side. It's going to end up here. And this coordinate would be +2, +3. So if you'll notice, this time when I reflected across the y-axis, my x value changed signs. So the pattern is that when it reflects across the y-axis, the x value changes signs. Our next example requires a little bit more work because this time we're reflecting across the line y = x. Still going to work the same way in that we're going to move the same distance away from the line as we are currently. It's just going to happen a little bit differently. So right now, R is at the point -1, 2, 3, 4, +1, 2, 3, 4, 5, 6. R is currently at -4, +6. S is at -1, +2. And T is at -1, 2, 3, 4, 5, 6, -1. Okay, and we're supposed to reflect it across the line y = x. Well, I'm going to start with point S because it's closest to the line. And S is here. I can't go diagonal to the line. Well, I mean, I can, but it's not really evenly spaced, so that makes it a little bit harder. But I can go, to get to the line, I can go to the right. So I'm going to go 1, 2, 3 units to the right. Well, now that I'm reflecting across this diagonal line, I can't keep counting right. I actually have to change directions, and I'm going to count down. 1, 2, 3. If you had counted diagonally 1.5, you would have also gotten there because you would have gone a half and then 1. So this is where the new point S is going to be located. And right now, S, this point, is at +2, -1. And hopefully you will notice that if this point originally S was at -1, +2, now it's at +2, -1. And hopefully your mind is thinking, oh, those switched. And they do. The pattern is that the X and the Y switch. The X and the Y switch. So if my original R was at -4, +6, my new R would end up at +6, -4. If my original T was at -6, -1, my new T will end up at -1, -6. All right, the next couple of examples talk about dilations, and if you'll think back to dilations, we learned that that means the shape gets bigger or smaller. So in order to dilate something, we need to know the scale factor, which they gave it to us. They said the scale factor was 2. And we also need to know the original point. So we need to know what A was to begin with. And right now, A is sitting at -2 and +3. So if I'm supposed to, and I'm going to go ahead and find B and C for that matter as well. B right now is at +1, 2, 3. And then 1, 2, 3, 4, 5. And C is currently sitting at +1, 2, 3, 4, and then +2. Okay, since my scale factor is 2, we said at the beginning of the notes that that means we're going to multiply by 2. So what we do is we take each of these numbers in here and we multiply them by 2. So I'm going to write that out. I'm going to multiply by 2. Well, -2 times 2 is going to give me -4. So my new A is going to be at -4. And +3 times 2 is +6. So the final ordered pair is -4, +6. I do the same thing for B. We're going to do that even though it doesn't ask you to, because I think you need the practice. So for B, I'm going to multiply each of these times +2. Again, because my scale factor was 2. 2 times 3 is 6. 2 times 5 is 10. Same thing with C. I'm going to multiply it by +2. 2 times 4 is 8. 2 times 2 is 4. So my new my new shape would have coordinates at -4, 6, and +8, 4, and +6, 10. All right, for example 7, we're doing another dilation. This time our scale factor is 1/2, which means my shape's actually going to end up to be smaller than it was originally. So I need to know, to figure this out, I've got to know what my ordered pairs are, Y and Z. That's all I'm going to do for this one. My original Y is right here, and that ordered pair is 2, 0. My original Z is at 1, 2, 3, 4, 5, 6, 7, 8, and then +2. So since my scale factor is 1/2, that means that I'm multiplying each of these ordered pairs by 1/2. When you're multiplying by a half, that means that you are just taking half of it. So I'm supposed to do 2 times 1/2, which means half of 2, that's 1. 0 times 1/2 is still 0, so my new Y would be at 1, 0. Half of 8 is going to be 4, and half of 2 is going to be 1. So my new Z is at +4, +1. So that's all that you have to do for the notes. So please pay attention to what you wrote down and make sure to complete your homework. Do as much of it as you possibly can this weekend because we need to get our project started in class when you get back on Monday and Tuesday. Have a nice day.